So we'll talk more about the formation of galaxies in general in the next chapter, chapter 15. But probably not so surprising, our galaxy kind of started out as a humongous molecular cloud. And fragmentation needed to occur. But also, we believe that because our galaxy is a spiral galaxy, there was a fair bit of rotation associated with our chunk of gas that ultimately formed these millions and billions of stars within our galaxy. So we needed to have the chunk of gas, and we needed to have gravity. Does that sound familiar? Okay, so this is a very oversimplified process of or few slides showing you the formation of the Milky Way galaxy. And again, we'll talk a little bit more about galaxy formation in the next chapter. But stars in our disk air region, we said that they have continued to populate new stars. And then, so we have an assortment of ages in our disk, and in our halo region, we tend to have kind of older stars. And a lot of the halo region stars are kind of congregated as globular clusters. And so this kind of shows you just briefly kind of how that might look. Okay, those are relatively old stars in the halo region. And then just a few slides showing you a little bit about the supermassive black hole in the center of the Milky Way galaxy. And these slides kind of look at that region of the sky we know to harbor the supermassive black hole, looking at different wavelengths and kind of getting more and more honed in. So looking at it in infrared versus radio. Okay, more radio and more infrared. And the one in radio emissions here, this blue one on the left, kind of talks about how we observe the swirling of the gas near the center of our galaxy, we know as a supermassive black hole, and that swirling, the orbital period of that gas actually is an indication of the mass of that black hole. So along those lines then, here we have each of these sets of dots actually represents a star that is orbiting a region of the sky we call Sagittarius A star. Sagittarius A star. You probably know Sagittarius is a constellation, and then actually this is a region of space that we believe that this object needs to be a black hole. And the reason for that is we can watch these stars over 10 years, a period of time, 10 years. We can watch these stars and their orbital cycle, and then we know, because of their orbital motion, what they are orbiting, which is a supermassive black hole. So I haven't mentioned it recently, but remember that my lectures, actually, I accompany them. You have available from the course website a playlist of YouTube videos, and the YouTube videos for this chapter and the next chapter are just great. So again, those would be something that somebody else put out there that just reinforces what we're talking about. So Sagittarius A star, the mass associated with that object, that black hole, is actually 3 million times the mass of our sun. And we can get a sense for the volume, and so the only way that mass can be in that small of a volume is if it is at the density of a black hole. So there you are, Sagittarius A star. And one of the things we're going to talk about at the end of chapter 15 is how galaxies, or I should say black holes in the center of galaxies, sometimes they are active and actually consuming matter. I shouldn't say that. Almost looks like they're searching for matter or stars to fall into these black holes at the center of galaxies, but that's not true. But matter will fall into these supermassive black holes, and sometimes they're active and sometimes they're quiet. And actually recently, fall 2012, the Milky Way's supermassive black hole, I think, has been feeding just a little bit. Something accidentally got close enough to fall in.